Okay. All right. Cool. So yeah, I was gonna following on from the introduction that Melanie made for me to this group. I was gonna tell you all a little bit about our work developing a virtual reality paradigm, which we call Numadelic Virtual Reality, which is specifically thinking about how to use virtual reality to kind of design experiences and phenomenologies that go beyond what we're kind of accustomed to day to day. And so I'll give a quick intro to it and go from there. So I guess the first thing wait, I'd like to say is just thank you very much for letting me speak with you. Looking forward to it. And just a little bit about myself and my background. I'm the director of a lab in Santiago de Compostela, which we call the Intangible Realities Laboratory. We do a whole bunch of stuff with virtual reality and augmented reality, primarily to date in the area of scientific simulation and visualization. Although increasingly we're starting to look at sort of how VR can be used to understand some of the mechanics of perception. And so that's what I'll focus on in this talk. And so quickly just want to say a bit about my own background because I wasn't originally trained as a neuroscientist. And I think some of that comes into how we're approaching virtual reality. And so I just want to just briefly talk about that. So from 2013 to 2020, I was in the UK. Then I was a Royal Society University Research Fellow in the area of computational molecular physics. And then in 2020, that should be 2020, not 2012, 2020 to 2027, I was awarded an ERC that kind of in a similar kind of area. And that was the time when the ERC award was made at the time when after the hard Brexit and the UK hadn't yet negotiated to stay in the Horizon 2020 arrangement. And so I left the UK during that time. And then recently in 2024, we got some funding from the Tiny Blue Dot Foundation to support some of the work that I'll talk about today, which is the sort of use of VR for looking at perception. And so this is a picture I like to show that gives an illustration of the kind of things that the lab works on. This is Robin Carhart Harris here participating in one of our early VR design sessions when I was still based in the UK. And this is Chris Timmerman here actually. And so we had some sort of what we called sort of design jams to formulate and build a lot of the technology that I'm talking about, which is all code that's developed in our lab, which is available open source. And I like to show this picture at the start because a lot of times when you think about virtual reality, you think about virtual reality as being an individual solo experience. And one of the things that's really unique about the virtual reality that we do in our lab is that we design experiences for groups. And so that allows us to have the flexibility to think about sort of social interactions and how we can think about the interactions between bodies as opposed to just sort of solo experiences. And that will be relevant in some of the things that I'll talk about a little bit later down the line. And so, like I said, my background's in computational molecular physics. This is Robin and Chris Timmerman in our lab. And this was actually the first time Robin visited the lab. I showed him LSD bound to the HT2B human serotonin receptor. And so again, what I like about this is they're clearly looking at something in the middle of their feet of them, but it's not visible to you, but it's completely visible and tangible to them. And this was actually what I showed Robin. This is kind of cool. This is our VR environment. And so this is the HT2B serotonin receptor embedded in a slab of cell membrane. And this is just the crystal structure that we pulled from the protein crystal data bank. What you're seeing is my first person view, and Robin is off to my right. And at this point, I told Robin, hey, Robin, why don't you inspect the LSD in its crystal structure binding pose up close. And so we kind of dove down into the cell membrane, which reminds me a bit of a kelp forest or something. And there's Robin looking at the structure of LSD bound to the serotonin receptor. And let me go to my next slide. Yeah. And so that kind of just gives a little bit of an intro of where a lot of our work comes from. And I think it's important. And I'll talk about the physics origin of our work moving on. And I wanted to say that I think one of the things for me as someone that's trained in physics and statistical mechanics, Carl, I think reading about your papers that Robin has shared with me and whatnot, I really like, I've found it very easy to understand the language that you often use in terms of statistical mechanics and free energy to understand these concepts. And so for me, it was a really good approach to neuroscience ideas. So thank you. Thanks for doing that. And in the spirit of kind of a physics motivated approach, I'll sprinkle little bits of how physics has motivated my approach as we go through this. But ultimately, this talk is kind of about aesthetics, and it's about design aesthetics and designing perception. And so when you make virtual reality content, you have to make decisions about how you design it. And so that's kind of what I'll talk about here. And then the other thing I want to say is that a lot of my interest in the neuroscience has arisen through my work as a digital artist. So experimenting with alternative aesthetic representations and thinking about how that works. And so I've shown digital artwork all over the world for the last decade in a variety of contexts. And some of what I'll talk about today of how we're using virtual reality to do different renderings are very different than what other research labs are doing. And it kind of came through this artistic channel. And then, yeah, just thanks so much for letting me talk, and maybe some cool ideas will come out of this conversation. So I thought I would start with this quote from Thomas Metzinger, which I imagine is probably a quite familiar concept for the people that are involved in the theoretical neurobiology community. But Metzinger is effectively describing, it's a sort of paraphrase of predictive processing. And he says, our best current theories of consciousness describe it as a kind of interactive dreaming, a dreamlike state modulated by the constraints produced by ongoing sensory input. Consciousness is a controlled hallucination based on predictions about current sensory input. Relative to the actual state of the world, all predictive representations are misrepresentations. And so for people involved in this group, I'm sure that these ideas are kind of bread and butter and I don't need to explain them so much, but I thought it was a nice starting point. And then the other thing I wanted to start with was a quote from one of my own papers, which I think kind of frames what we're doing. And which is when you're using virtual reality, you have the ability to construct aesthetic representations that go beyond sort of conventional models that we formulate about the world around us. And so I wrote this paper recently where I started out with this quotation, which I'll read. It says, virtual reality enables the construction of immersive environments with the potential to represent a vast range of phenomena limited by little more than imagination. Nevertheless, the vast majority of VR content is remarkably limited. Broadly speaking, VR tends to follow the dominant aesthetics of the metaverse, which generally aims to maintain fidelity to the sorts of scenarios and appearances which most people encounter during their day-to-day experience. Metaverse aesthetics are largely composed of graphical representations of man-made or natural structures and landscapes inhabited by human-esque or animal-esque beings whose detailed appearances generally look like one might see in the real world. Within research settings, VR tends to adopt a similar aesthetic. And so I put this quote here because it reinforces this point that in VR, the sort of design space is potentially unlimited, which opens up a really interesting range of things that can be studied. But in general, it's constricted to what we've already seen. And so I just think that's a kind of interesting irony. We have this really powerful technology that can enable us to sort of look at phenomena on the sort of outer frontiers and edges of what we encounter in day-to-day phenomenology, but that's not what people are doing with it. And that's in part driven by the fact that a lot of VR is sponsored by the US military and the gaming industry, which generally tend to you want to make simulations of what the world already looks like. And so most VR uses symbolic representations that look like the real world, right? Which another way of saying that is it kind of reinforces our top-down cognitive priors that the models we derive of what the world looks like around us. And so I just have some snapshots of some typical VR games that are and sort of research that are used in a research context in many cases. One's a sort of experience where you can go walking in the mountains, and another one is you can kind of be in a post-industrial landscape like Detroit or something. And then the other is, you can kind of choose your avatar and what it looks like. And there's a really interesting pop science article about VR, which is a funny read, but it really makes this point that we have available this huge design space with digital technologies, but we're generally just using it to reaffirm what's already there. So yeah, before I dive into what we're doing with VR, I just wanted to set the stage a bit by talking about how we think about self, because ultimately what I'll talk about is kind of probing the limits of what we imagine ourselves to be using VR technology. And Anil Seth provided a nice summary of some of the aspects of the sort of perception bundles associated with being a self in the book that he wrote in 2021. And I find this a valuable schematic. He talks about our embodied self, which is our identification of emotions and moods, and that's often associated with a sense of body ownership. But that's, things like phantom limb syndromes or sensations of pain that are in missing limbs or rubber hand illusions to challenge the conventional sense of embodied self. We have the perspectival self, which is, the view of the world that we have from a particular, huge for most people, visual perspective. And obviously that's challenged by things like out-of-body experiences. We have a volitional self, which is often associated with a sense of free will and agency. That's challenged by disorders like schizophrenia. We have a narrative self, which is how we construct continuity over time, right? So this is stories we tell about ourselves, about our history and our future. We have senses of regret or shame. We can even regret things in the future or anticipate bad things happening in the future that haven't even happened yet. The sense of narrative self is often perturbed by disorders like dementia or amnesia. And then we also have a social self, which is how we perceive others perceiving us. So it's kind of like second order perception of ourselves. But this, again, is often challenged by disorders like dementia. And so Anil makes the point that our sense of self, though it seems very concrete and nothing could be more real, in fact, is quite fragile and can be deconstructed in a range of ways. And virtual reality has played an important role in looking at how self can be deconstructed over the years. So I imagine everybody here is probably aware of the rubber hand illusion. This was a illusion where if you see a rubber hand in your own hand and they're both stroked simultaneously with a feather or something, you develop a sense of ownership over the rubber hand to the extent that, if it's threatened, you actually feel a sense of dread and fear. And this is a kind of classic illusion. It's been around for a while for thinking about senses of body ownership and the idea that you can kind of develop a sense very quickly of owning something that's clearly not yours kind of came as a surprise when it first arose. And then in 2007, there was 2 science papers where they did a similar thing, creating body illusions in virtual reality. And so the model was you put somebody in VR and then you show them their body, but like a few meters in front of them. And then if you stroke both bodies again simultaneously, the people would develop, the participants would develop a sense of ownership over that other body. And so this was kind of moving toward a sort of out of body experience. And it showed that people could develop a sense of identification with something that wasn't necessarily localized in the normal place that you would think of your body as being localized. but even using VR in this context, it was very much locked in an aesthetic realm where things look very much like the real world. So you're in a simulation, usually of a laboratory. The body you see looks like exactly your body. And so you're playing games with perspective in VR, which you can do in most normal video game engines by changing the camera perspective and the camera position and the camera orbit and things like that. But the views that you see, what you perceive, is very much the phenomenology that looks like things in the real world. Mel Slater picked this up with Olaf Bonke a few years later, looking at in more detail experiences of body transfer in VR. And I just highlight, one sentence from the abstract of this 2010 +1 paper they wrote, which says, the results support the notion that bottom-up perceptual mechanisms can temporarily override top-down knowledge, resulting in a radical illusion of transfer of body ownership. And so they're very much using the language of predictive coding to describe this phenomena. And I'm going to return back to this idea when I talk a bit more about some of the stuff that Carl's done with Robin Carhart Harris in the context of psychedelics, but I just wanted to set the stage here for now. So I guess one of the questions that's driving this work is really like, how flexible are the phenomenological frameworks that enable us to understand ourselves and others as selves? Kind of working within this schematic that I presented from Anil Seth's book. And in what we've done with virtual reality, I guess there's two main questions we've really been probing. The first is, what's the minimal phenomenology required to identify oneself and others as selves, right? So we're accustomed to seeing ourselves as bodies with hands and legs and noses and eyes and ears and fingers and thumbs. And we're accustomed to a certain kind of way that the mechanics of those bodies move. But is that really what's needed to identify oneself as a self? And then the second question is, how flexible are, normally when we think about a body, almost the definition of a body in Newtonian mechanics is something that's solid and bounded. And I guess there's a question of how important are those notions, how flexible are those notions of solidity and boundedness in defining our sense of self? And Thomas Metzinger has a ongoing interest in this idea of what he calls minimal phenomenal experience, where he talks about this idea of minimal phenomenology. So I just wanted to recognize him as being someone that's helped inspire some of these directions. So I want to start with just a quick question. We're going to talk a bit about entropy. And I just want to ask the people that are here, there's not many people here. So when I show this video, what do people see here? There's no right answer to this question. I'm just curious what people think this is.
A light glowing, a soul.
Yeah, definitely a light glowing. Absolutely.
And growing.
Anybody else see what? There's no, like I said, it's like a Rorschach plot or something. It's just like, what do you see here?
I make an immediate association with Star Trek.
Yeah. There's definitely something a bit supernova about it. Yeah. Yeah. Some people see a light at the end of a tunnel. Some people see a sort of a heartbeat. Some people see the pulse of a breath. So there we go. And then I have just a second sort of art question here, which is, when I show this image, what associations do people have? Again, there's no right answer. It's just like Rorschach here.
Yeah, that looks like a human image.
Yeah.
It looks like a snowman, but made from smoke.
Yeah, snowman made from smoke. Some people see a nebulae.
Yeah.
Some people see an owl. Again, there's absolutely no right answer, but I wanted to show those two images because one of the things we've been thinking a lot about as we've been experimenting with minimal phenomenology and in virtual reality is we've been thinking about, like, how can we characterize the entropy of symbolic representation, right? So entropy is, in statistical physics, is like really easy concept. Calculating is really hard, but in principle, it's a pretty easy concept. it's like the number of states a system can occupy, right? Like just counting the states. That's where it gets really hard. It's how to count the states. But I like to say that these two images I showed are high entropy representations because they're because people can project a number of different things onto them in the same way that people can project onto Rorschach plots, for example, right? And so when we talk about this form of aesthetics, we say it has like a high symbolic degeneracy, which I think I'll come back to why I think that's important in a bit. But if I would have showed you something, you know, like a picture of a tree or something from a social media feed, I think we would not have had the range of descriptions of what that thing could be. And so one of the areas we've been experimenting with in VR, sort of coupled to the sort of ideas that have been written about by Carl and Robin and others in relation to brain states under the influence of psychedelics is like, well, can we project ideas around entropy to the aesthetic domain? And then does aesthetic entropy potentially have any coupling to neurobiological entropy? And that's that's an open question I just want to put out there for everybody. I don't have an answer to it, but these are like gestational ideas that I think are interesting once you get away from always thinking that VR has to be a simulation of the real world. So the aesthetic that we've adopted in VR actually has its origins in the work I've done to visualize the dynamic of quantum systems. And I just want to say something about that very briefly. But one of the really important, quantum mechanics is weird. Everybody knows that. Nobody really understands it exactly, but there's mathematical equations that have certain consequences. And one of the things about quantum mechanics is it gives you this sort of what Niels Bohr called complementarity, right? So you can describe something as a particle or as a wave. So you can describe it from using a material metaphor or an energetic metaphor. And sometimes you choose one and sometimes you choose the other. Usually when things get very small, you choose the energy metaphor because the material ones break down, but that's not even true always, right? Einstein won the Nobel Prize for the photoelectric effect, which is describing light hitting a metal surface as little marbles. So even when things get small, sometimes the particle description is good. And, you know, this is one of the things that annoys particle physicists because how can you have two theoretical descriptions that can be applied at the same time? And Niels Bohr, I mean, he called it complementarity, and he kind of just said we have to learn to live with this. But the point is that, you know, Einstein, Bohm, Schrodinger all had different ways of describing this complementarity. Einstein has a famous equation within relativistic quantum mechanics that, you know, relates energy to matter. David Bohm said all of matter is frozen light, so all matter is a kind of frozen energy. And then Schrodinger's famous wave equation basically says everything is some kind of blurry, energetic wave-like thing. So something you think of as a particle is in fact some dynamic process. And so, you know, Einstein and Schrodinger and Bohm weren't the only ones to say this. This is also something that, you know, creeps up in some mystical and spiritual traditions, this idea that there is this energetic reality that kind of transcends the material reality. But then in physics, it's been formalized in a really nice way. And there's some other interesting things about quantum systems when it comes to the mixing of bodies. So in a quantum system, if I take two bodies and they constructively combine, I actually completely lose track of which is which because they make a superposition state where they're both blurred together. In a classical system, if I take two balls, A and B, and I mix them, they'll always keep their identity. If I label them, they always keep their label. Whereas in a quantum system, they actually lose their label to combine something new. And this is an important point for one of the experiences we've developed, which I'll show you in a bit. So I just want to talk about a few principles of quantum mechanics that have found their way into the aesthetic that we've designed. And so this was some work I published like back in 2017. And what we're trying to do here is we're trying to visualize the dynamics of what happens when a photon of light hits a leaf. So this is a light harvesting complex that occurs in, well, this one's actually from purple bacteria. This isn't actually from a leaf. This is from purple bacteria, but this is a light harvesting complex, and the time is in femtoseconds. And what you're seeing is the moment a photon impinges on this light harvesting complex, you're seeing how the energy excites an electron, and then that electron becomes delocalized around the entire ring. And we worked really hard to make this simulation. The simulation used used a lot of GPUs on the Stanford supercomputer at the time we ran it, running over weeks and weeks. And then we worked really hard to make a video, because actually showing waves of energy being delocalized is a real challenge. And we'd actually developed new visualization algorithms to help visualize this energy slowly being delocalized. And so these kind of blue flickering cloud things that you see is the dynamics of this electron as it delocalizes over this ring. And what I'll talk about moving forward in VR was we literally took these same algorithms we used to visualize quantum systems, right? Quantum bodies, and then we mapped them onto human bodies. So that's why I'm showing you this. If this is super random, why is David showing us quantum electron transport? It's because these are the same algorithms we took to represent human bodies. So that's kind of, I'm explaining where a lot of this came from. And there's two kind of influences. The first influence is the research into quantum mechanics, where we literally took the same algorithms to render quantum bodies and put them in VR to render human bodies. And I'll show you some videos of that. But the other place that a lot of this work came from is in 2006, I had a near-death experience. So I was walking in the mountains and I fell like 30 meters, actually. It's like a total miracle that I'm alive. I had severe multiple trauma. I didn't walk for a year. I had a thoracic contusion. So when I hit the floor, the most acute thing that happened was the blood started leaking. My lungs started to fill with blood. And I was basically suffocating for the 4 hours whilst I was waiting for a rescue. And I had an out-of-body experience where I separated from my body and started orbiting my body like the moon would orbit the sun. I separated laterally from my body, and I perceived my body as this pulsing light. And with every inhale, the light would get a bit brighter, and with every exhale, the light would get a bit dimmer. And so I kind of had a firsthand experience myself of the sense of self, as Anil Seth talks about, my perspectival self not being located in the body. And moreover, it wasn't even my body in the kind of conventional way that you'd recognize a body, but I had a very strong identification of this pulsing light with my body, especially given that this light was synchronized with my breath. And so what we've done moving forward is we've used virtual and augmented reality to create an aesthetic paradigm where we can basically take bodies and we can dissolve them into light, and we can play all kinds of games with the pass-through functionality and all the new tricks that are available on the latest generation of AR and VR technologies to construct fluid representations. We have like we call it the reality dial. We have like a dial where we can turn the real world on, or we can fade the real world away, and then we can construct these like luminous representations of multiple bodies in shared virtual spaces. And I have to say, it's like, if you guys ever want to invite me to London to come show you a demo of this, I would be happy to do that. It's very hard for me to explain this on a two-dimensional talk, because this is intrinsically like an embodied experiential thing. So I'm doing the best I can with videos on a small Zoom screen to give you a sense of what this is. But if you were in VR, this is like literally, and someone was sitting across from you, this is literally what you'd be seeing. You'd be seeing the person as you would in the real world, and then they would fade away and transform into light. And that light would be exactly located where their actual body is in space. It's hard to explain this if you don't experience it, but I'll do the best I can for the remainder of the talk. And so we basically have like a continuum where on the one hand, we have extremely minimal representations of bodies in space. And then on the other hand, we kind of have exactly like what a body would look like in space. If I asked you on the right-hand side, what is this? You'd say, this is a woman sitting on a cushion wearing a VR headset. If I asked you on the other side, what is this? You'd give a whole range of other answers. And so one way of thinking about this is the symbolic degeneracy decreases as you move to the right, and it increases as you move to the left, because the space open, the sort of the state space available for describing these representations changes as you move to the left or to the right. And we call this aesthetic a Numadelic aesthetic. And we did this very specifically. We named it this very specifically to disambiguate it from psychedelics, because I'll tell you why in a few slides. Because when we published initial comparisons with psychedelics, we got a lot of kickback from the psychedelic community, and so we decided it was a good idea to rename this aesthetic. And we called it Numadelic because pneuma in Greek means breath or spirit or soul, and dayline means to reveal or make visible or manifest. And a lot of people, when they saw representations like this, they said it, reminded them of spirit, because energy is often a metaphor for spirit for many people in mystical and religious traditions. So that's kind of the origins of that name, and it just sounds nice. So that was why we named it that way. And so the chain of reasoning that really led to the Numadelic aesthetic was as follows. To accurately represent the dynamics of small bodies like electrons, we need quantum descriptions. Quantum descriptions use an aesthetic in which bodies are represented as delocalized energetic processes, right? They're not firmly bounded, they're diffuse and they're dynamic. And so what if we apply similar representational aesthetics to human bodies? So what if we represent human bodies at the macroscopic level as delocalized energetic essences? So normally, we only think about quantum aesthetics for the microscopic, but what if we just said, okay, let's try that and see what happens? So I just have again, it's hard for me to represent this on a screen. And if at any point there's any interest, I'd be happy to make a trip over and show folks this if they want to see it, or even organize. You don't even need to be in the same place. You can be in different virtual spaces. But I just have a very short video that gives you a sense of what this looks like. So if you're in VR, this is literally what you'd be seeing. You'd be seeing this girl sitting away from you, and then some people might dial in from a different part of the world, and they could appear in the space out of nowhere. And then you would see the sort of dynamics of how this unfolds. And I'll just show this for a few minutes just to give you a sense.
David, what are the little bouncing lights? What do they correspond to in reality?
Yeah, that's a great question. So there's one central light at the center of each person, which it's inspired by like the heart. So it's like we tell people to imagine that as their heart center. And then every person on their hands has two small lights, which they can illuminate. So each body is like a kind of energy cloud. And then they have a central light located approximately where their heart would be, using kind of inverse kinematics algorithm tricks that we designed, and then the hands. So yeah. And that's more for spatial reference than anything else. But like this is a platform technology that we've written. So every single aesthetic parameter in this system can be modulated and varied. So there's actually like about 200 aesthetic parameters that you can vary to create an infinity of different, it's not infinity, but it's a very big state space of aesthetically what it can look like. So the heart light and the hand lights don't have to be there, but we generally find those are pretty helpful for people to get oriented in the space initially.
Thank you.
Yeah. So this quotation here, you become all anonymous, just beings of light. It allows you to let go of your own sense of ego. This is a really typical, we've tested this framework now on thousands of people over the last like 6 years. And this is like a really typical quotation that came out of these experiences that we've designed. So I'll put some quotations moving forward to give you a sense of this. But one of the really cool things we discovered is a kind of, I guess, a new illusion, which I wanted to emphasize here. VR has kind of been locked in rubber hand illusion for the last 20 years. And I think we've kind of discovered a new class of psycho-somatic illusion. And I really value people's insight here, how to think about it. But It's something we call energetic coalescence, and it's something that's only possible in VR when people are not located in the same physical space. So one of the things I mentioned earlier is that, when people do these experiences, they're in the same virtual space, but they don't have to be in the same physical space. So there could be someone in London, there could be someone in Portugal, there could be someone in Peru, there could be someone in Chile, and there could be someone in Germany. And they would all be in their own little place around the world. But they would be together, like sitting in a circle in the virtual space. And because there's no physical bodies in the space where they are, so I've shown you here on the left-hand side, everyone's sitting in a circle. So you see 5 little orange people and there's 5 little lights. But one thing that's really cool is now everyone stood up and they moved toward the edge of their mat, right? They walked forward a step and now they can completely overlap. So what I've shown in the bottom panel is what it looks like from a top-down view. You see there's 5 sort of little wave functions that we've rendered, which are just the centroids are located where the heart center is. And now when they all step forward, they all completely merge. So I literally am including 4 other people in my self-representation. And this is something that you can only do in VR, basically, in embodied virtual reality. There's no other way to do this. And this is what it would look like if you were in there watching 3 people do it. So you'd literally be seeing 3 people, 3 light bodies that would be completely merging with one another. And the reason I'm showing you this is because it's associated with it leaves a really strong perceptual mark on people. I just have some quotations from some of our research over the years with quotes that people have made, and these are quite representative. I'll just read a few of them, right? You can sense an imaginary presence around the glowing light, and you can give it space even though there's no barrier there other than imagined. We could get closer than in real life, which felt more intimate and connecting, nearly as much so as with a partner, child, or pet, even though we were in different places around the world. I was struck with how quickly the abstract lights grew to hold tangible meaning as other people. It was especially poignant during coalescence when we moved toward the center and felt as if we might collide or enter each other's personal space. I can just literally walk inside of people and it's quite sensuous. I found it really strange at the start when we were getting closer and closer, and then the boundary of personal space all of a sudden dissolved and it was like, oh, actually, this is kind of nice. I could feel subtle changes in my hands as something were passing by, something physical. I got quite emotional. I got this surge of emotion where I don't know if I wanted to gasp or cry or what, but I was kind of shocked and awe. And so I highlight this because this experience that we discovered using the power of virtual reality with clouds, with Google Cloud effectively is how we run this, really creates like physical and emotional sensations for people that are quite reproducible and quite strong. And really interesting, this energetic coalescence, it's not always associated with a positive valence. On a few occasions, we've had people, in particular people, I think, that have a history of trauma. Actually, when the coalescence part of the experience arises, they've refused to do it. And when this first happened, I was very confused. I was actually guiding the session, and I said to the person, "Are you okay?" And they were like, "Yeah, but I'm not doing this. Like, I'm going to leave the session." And I was like, "Well, why?" And it was like, "I'm not going to overlap my light boundaries with the other people here." And I was like, "Okay." I said, "You realize that like those lights in the space aren't actually there with you, right? They're just projections of your own mind as being people." And she was like, "Yeah, I don't care." And she left. And I initially got kind of upset about this because it ruined the session for the other participants. But the more that I thought about it, I actually thought, wow, that's like a real indicator of the potency of the illusion, that someone refuses to do it because they've attached so much meaning to the lights in the space with them, even though there's actually nothing there and it's purely a projection of their mind. So yeah, so what we did was I just want to show, I'm going to skip through and go back to that. What we did was when I talked to Robin about this stuff, I was showing him what people were saying, and we ran this experiment. We called it Isness Distributed, where it was basically a citizen science experiment where we got a group of what we called VR nodes around the world to gather participants. They were all remotely located. And then we would run 4-person sessions, and we did this for like 100 people. And then we ran experiments, and we did we did exit interviews, and we had people answer a bunch of questionnaires, and Robin really guided like some of the research design for this. And one of the things that he recommended is he said, well, why don't you compare the results that you get for these experiments to what we do in psychedelics? And so he showed me what they do for their psychedelic ceremony study protocol, which has a whole suite of questionnaires that they use to kind of analyze the phenomenology of the experience. And a lot of the questionnaires were originally like developed by the Johns Hopkins lab. And he said, why don't you compare against that? And so that's what we did. And we measured, I'm just showing results from one of the scales, which is called the MEQ30, Mystical Experience Questionnaire 30. Like, it has a lot of shortcomings and problems, and I don't necessarily want to argue about those here. But the thing about this questionnaire is it's been applied to almost 10,000 people over the last decade. And so whatever shortcomings are, it's been so consistently applied that there's actually a really nice data set over the years showing how the 4 different factors of the MEQ30, IMPT, ineffability, sort of M is like a sense of unity beyond yourself, P stands for positive emotions, and T stands for a sense of transcending space and time. What this questionnaire shows really consistently is that placebo doses of psychedelics score very low on all 4 factors. Very high doses of psychedelics score very high on all 4 factors. Low dose psychedelics are in an intermediate range. Moderate to high dose of psychedelics is kind of in this green band. And the stuff that we did are the 2 isness experiments that we ran are kind of statistically indistinguishable from moderate to high doses of psychedelics. There's this gray band is statistically indistinguishable from this green band here. And so showed this to Robin when we got these results, and he got, he was really surprised. I was really surprised that we could get results like this on a scale like this from a 45-minute VR experience. And since that time, I've been trying to understand, like, well, why? And so one of the things that I, have been reading, and which Robin pointed me to when he wrote it with Carl, was this Rebus paper. And again, I highlight the kind of one of the take-home messages. And so it's a paper I've read a few times, but high level, psychedelics work to relax the precision of high-level priors and beliefs, thereby liberating bottom-up information flow. And I was really struck by the similarity of that language with the way that Mel Slater and Olaf Blanke talked about the mechanisms they were hypothesizing to be at play in the body illusion in virtual reality, which is a very similar kind of statement. Right? The results support the notion that bottom-up perceptual mechanisms can temporarily override top-down knowledge. So, you're in VR, your body's not a light, but nevertheless, you have this very strong emotional and physical identification with this environment. Similar with psychedelics, like, some of the things you experience under the influence of psychedelics, you know that you're in an illusory kind of, psychedelics I see as a kind of virtual reality. In fact, you're in a virtual state of being, it's temporary, but nevertheless, you have strong associations with the time that you're in there. And so, yeah, we were shocked by this, and I guess I'm gonna I'll wind down the talk now and maybe just talk about a few interesting aspects of this, and then maybe if there's time to talk a little bit, that we can do that. But oh, by the way, I just want to say, I show you these results, but there's other things we compared to for the VR against other psychedelic studies, and basically for a whole range of different scales, we get the same results as psychedelics, statistically indistinguishable. This is one, like, how do you feel in relation to the group? And you give people this pictograph where it's themselves as the orange circle and other participants as the blue circle. And then people have to rank before and after the psychedelic experience, like how have they changed from pre to post and their sense of connectedness to the group. And for VR, we get a pre to post of 1.2 to 2.9, and that's like the post that they get for this PNAS paper for when they were looking at people taking psychedelics in another study. And the results also really similar to a bunch of the stuff that Robin's published over the years. So again, just showing that on a range of different scales, reproducibly, the VR gives these questionnaire results that are comparable to psychedelics. We wrote 2 papers about this, but now there's a bunch more papers because now a whole bunch of like at least 5 labs around the world, neuroscience labs around the world, have gotten interested and started using this technology, using the VR technology in their own labs to do studies. So now there's been a lot more papers, but these were the 2 first papers that kind of sparked interest. Joe Rogan talked about it on his podcast. It's kind of funny. I won't show this video right now, but after Joe Rogan talked about it, or no, the reason Joe Rogan talked about it was because there was this MIT technology review, which I think the headline is a bit overblown. I don't think VR is the same as psychedelics, and I don't like it's clearly different and the mechanisms are different, but nevertheless, if you look at the sort of psychometrics that are used to evaluate psychedelics, the VR seems to give the same results. But nevertheless, this article, this popular press article, created a really, really cool buzz that has led to some interesting projects. And it's like a nice, that journalist actually wrote a nice article about the origins of where things come from. So yeah, so that's pretty much what I wanted to say. I'll just have a few thoughts in closing. So after this, we did this work with Robin. We basically, there was a retreat center in Colorado where psilocybin is legal that got in touch and was like, hey, we want to use the open source software to use the Numadelic VR as part of like retreats, psilocybin retreats we do in Colorado, right, where things are legal. So Robin has ethics approval for what's called like observational studies. And so the retreat center, they gave people psilocybin, and then they let people go into Numadelic VR at peak. And we were really interested in this because we thought our hypothesis was we thought it would be an additive effect. We thought that if we know that Numadelic VR gives psychometric results that are comparable to psychedelics, and we know that obviously psychedelics give results that are comparable to psychedelics, then what we should see is maybe like even more bang for your buck. So really, really significant effects under the influence of the combination of VR with psychedelics. But instead, we kind of found the opposite, right? We found that like about 40% of the participants reported that the phenomenological effects associated with the trip were diminished the instant they entered a Numadelic VR. So people are at peak tripping and they're experiencing all the normal sort of subtle perceptual distortions that you experience under the influence of psilocybin. They put the headset on, they go into the Numadelic environment where, you know, they just see the bodies of the other people around them as lights. And like 40% of them say that that instant, the trip is gone and they don't feel like they're tripping anymore. And then as soon as they take the headset off, they say it feels like they're tripping again. And this is kind of one of the things that made me want to really present to this group is how to understand this observation. And I found predictive processing to be like a really rich explanatory framework for that observation. And I don't know, I'll offer up the explanation I've been working with and see if you guys buy it or if you think it's totally crazy. But I mean, so just this is my very, very, very simple, stupid schematic of how, you know, predictive coding works under waking consciousness, right? So in this case, all the black arrows dominate and the blue arrows are small, right? So the bottom-up information, the bottom-up inputs are, you know, there's not much of them getting through because, you know, what you're paying attention to is dominated by your top-down models. Under psychedelic states, you know, they're comparable, right? So now you see the blue arrows have a similar kind of width as the black arrows. So that means that more bottom-up information, perceptual level, is kind of slipping through the net. And so if you just like take that very simple schematic and try to rationalize those results, where I've arrived, and which I think is a really interesting thing to maybe test moving forward in a more systematic way, is maybe the reason that the effects of the psilocybin trip diminished is because when you enter a Numadelic VR, you don't actually have a well-formed prior for that environment. And so the rebus idea that, Robin and Carl published is that psychedelics are effectively kind of liberating the force of the model that you're projecting on the environment. And so it's like the distortion, the de-ridification of that model is kind of associated with the effects of the trip. If I put you in a Numadelic environment where you don't have a pre-existing model, in a sense, there's nothing for the psilocybin to distort. And so I'm wondering if the reason that so many people reported that, it was not an additive effect. In fact, it was the reverse. It was like the trip stopped as long as they were in the Numadelic VR, is because there was no pre-existing model. And I think, as a explanatory framework, predictive processing, I think, offers a really nice way of thinking about that. I mean, obviously it needs to be tested, and it would be interesting to do that. Then I think there's other competing explanations also for what happened. But yeah, I think this is kind of a fascinating area for observation. And I guess alongside that, it might be that Numadelic VR is producing these psychometric effects that are comparable to psychedelics, because because you don't have a pre-existing model, it's allowing you, in a sense, to be more sensitive to bottom-up perceptual information that arises because you don't have a very well-formed prior. So that's what I've prepared. Let's leave you with a few thoughts, which is most VR and immersive technology more generally is, I think, reaffirming cognitive priors. I think, combine ideas from physics with kind of questions and perspectives from neuroscience, we can experiment with what we've called, weakly representational Numadelic aesthetic paradigms. A lot of work now, a number of studies reproduced by labs around the world, has shown that, these Numadelic VR paradigms have the potential to elicit phenomenological effects which appear to be comparable to some altered states. And then, just more generally, I'm interested in any potential areas or applications where, you all think this could be interesting for further research questions. I'm working on a project with Melanie Bali, for example, right now, where we're doing high density EEG measurements of people whilst they're undergoing the coalescence experience to see if we can see any sort of neural correlates for that particular experience. And yeah, that's what I have. And at the moment, we're currently running a more sort of clinical applied trial using Numadelic VR to support groups of people who have cancer diagnoses. And the idea is to offer them an opportunity to kind of, well, NDEs tend to reduce death anxiety. And the Numadelic aesthetic is grounded in no small part from my own NDE. And so the idea of this project is that if we know that NDEs reduce death anxiety, perhaps we can offer people the opportunity to have these experiences of what an NDE might be like, and perhaps get some, they might derive some sort of reduction in the fear and anxiety that's associated with facing a life-threatening illness. And so we have trials ongoing with that, with a number of hospitals and palliative care networks in Spain, and we're looking to expand that out in other places that might be interested. So yeah, thanks very much.
Thank you, David. I invite everyone to unmute and turn on their videos and give David applause. That was great. And I'm sure the Q&A will be quite rich. Now we open the floor for questions from the audience. If you have any questions, don't hesitate. So maybe I'll start I'll start first. So many so many things and connections came to mind hearing you talk, David, and I'm sure what we are doing at Sussex, given the ERC grant that me and other people are working on, which was awarded to Anil on computational neurophenomenology, and within this grant we have some research inquiries, research lines, and one is different types of illusions, modeling different types of illusions. We have Canisa illusions and uniformity illusions that we want to model and do some experiments with. We have also gist perception, and obviously there is the dream machine, which was using VR at
Yeah,
Sussex.
yeah,
You know that case. I
I
met
know about that. Yeah.
just yesterday, so Keisuke Suzuki. And when this is done, when we record this, I'll show this to Anil, and we'll probably brainstorm and be in touch with you just uh, to see if there is anything our labs can do together, because I see a lot of cross-pollination potential here. But yeah, so this setting aside the comments, one question would be, and I'm interested in
I should say Dream Machine is cool because it's one of the few examples of VR being used that is not for like grounded in the sort of trying to simulate normal phenomenology. So thanks for bringing that up because there's not many examples of using immersive digital tech to go beyond that framework. So yeah, thanks for mentioning that.
Yeah. So this non-mundane VR uses that and your stuff is the only things I know of, admittedly.
Mhm.
So yeah, and I definitely this is a very, I would say, potentially prolific line of research in investigating the structure of our experience. If we can expose people to non-standard, non-mundane world models or worlds that they are called to generate a model for, and then we are intervening on the priors when the model is formed. That's certainly something very interesting. So now I'm curious whether you've ever considered using this Numadelic VR environment to test various hypotheses about what people claim are essential properties of our phenomenology, or rather phenomenality. You know that in IIT there are the axioms of experience that are supposedly true of every experience. So those would be phenomenal properties that are essentially true of every conceivable experience. And there are other people saying things like unity, or things like intentionality, things like some form of subject-object division, or like some properties of experience that are inevitably there. Have you ever probed this kind of space of possibilities, like having people do some Numadelic experiences and asking them, okay, what do you think about your experience right now? In what way is different? Have you found an invariant that's not there, or have you falsified one that you thought was there?
Yeah, well, that's a really I would love to understand in a bit more detail exactly what what you think would be interesting to test in that respect. Like I would be super interested. Certainly what we have found is that when you have this coalescence experience, we've found that maybe you can help me articulate what we're looking at in a more formal way, but we kind of stumbled on this when I talked about the mixing of quantum systems, how identity disappears during a mixing process. That's kind of why I talked about this, because the aesthetic we've represented literally causes you to lose your sense of identity within this larger field that's constructed in front of your very eyes. And so what we found is that people often have a certain sense of like resistance to that initially when it happens, but then they kind of relax into that sense of spaciousness, and they still identify as they identify as being a kind of merged self with the others. So I mean, we haven't found, like, we're looking for neural correlates of that right now, but certainly identify bodies as being distinct, atomized individual objects seems to be challenged by this particular illusion that we've stumbled upon. And so, like, that's the one thing that I think we have, that I emphasize in this talk, which is quite interesting. And then the other thing I think is the notion of, like, boundedness. So when you're in this space, you don't have a hard boundary like we're used to seeing typically when we, like, see another body. We the way that our eyes work is that we see we see light at certain wavelengths that constructs, like, macroscopic boundaries. But in that environment, we can play tricks with lights where things slowly dissolve out into their environment. And what we found is that people seem, when we ask them certain kinds of questionnaires, they express a sense of an expanded sense of self. And as we modulate the variables like contract or expand the self, actually they report, when you look at it in terms of, like, just psychometrics, like, I want to emphasize, we're just in the initial stages of looking for neural correlates with this, because, I'm learning about all this stuff on the fly, but certainly we're finding that people's phenomenological experience that they're reporting is directly associated with a sort of sense of expansion or a sense of contraction that links into basically how you draw the Gaussian envelope of how fastly the lights fade out, if it's a broad Gaussian or if it's a very narrow Gaussian.
And is this sense of boundedness specifically referring to their sense of self, or only to the entirety of experience? Like it's sort of the aperture of the entire experience rather than the self experience only?
Yeah, I don't think we've probed that. I don't think we've specifically looked at that, but I think that would be a really interesting thing to think about how to ask about.
Interesting.
Yeah.
And yeah, the thing that she said about this identity dissolution is like you are doing osmosis with something, so osmosis with the field basically, and you are just losing this sense of sharp divide. Yeah, there are so many things, and I don't think we have even prepared the language to describe this kind of experiences very well. So what you are doing is forcing us to think about non-standard ways in which not only we experience, but we should try to describe experience itself, and that's very interesting to me. So,
Yeah, so, like, what I just, like, just to follow up on that a little bit is, like, then this is where the physics hat is really useful, because, like, in fact, we are fields that are in a continuous communication. We're not discontinuous entities. Like, we are actually we're in a continuous field interaction with everything around us. We tend to think of ourselves as discontinuous, isolated objects because of how visual perception works. But I think what's really interesting about this VR framework is because vision is such a dominant sense, it just offers you that as, like, here you go, like, here is how you can actually see that you are not discontinuous from those other people. You're actually in a continuous field of interaction. And so I think that's why I like to use some of the language from quantum mechanics, because it actually, like, there's a bit of a language there for this kind of graphics rendering strategy that we're doing, literally, because we took those algorithms we used for atomic bodies and we applied them to human bodies. And so I think a bit of the language might be latent within there. And so it could be really interesting to go into that in a bit more depth and see if there was any metaphors that could be valuable for, like, I'm not talking about quantum biology. I'm not being a nut job, but I am saying there might be useful metaphors within that linguistic machinery of physics as constructed over the last 100 years for then mapping it on to sort of new elements of like transpersonal experience.
And I fully agree with you. One of the problems in consciousness research and being immersed in this field for a while now and seeing what people are working on, there's definitely a sense of penury of metaphors. We are using the same old metaphors, and we have constructed theories on big theories that we now supposedly test adversarially on old metaphors, like workspace metaphors and other types of metaphors. And yeah, I think this kind of new languages for describing experiential regularities, I think it's potentially very powerful, and it's some definitely out of the box thinking that the field needs, at least according to my impression. So now I'll pass to Andreas to ask a question.
Yes, thank you, Robert, and thank you, David, for your profound creative talk and for the methods you introduced. Just to well, and then first to say, like, I think you're a great communicator. I love how you draw on your experience as an artist, on your own personal near-death experience, on molecular, physics, and on all of this. So that's really makes this profound, I think. And then to just quickly add to what Robert said, there are, for example, theory of consciousness. Are you familiar with integrated information theory, IIT?
I'm familiar with it. I would not claim to be an expert in it. I sat through a workshop with Robert
Oh,
in Venice trying to understand it and did my best for 10 days, and I'm probably understand a little bit of it. So
okay. So you understand more than me, but I want to say that see, they looked, they based some of their uh, approach on introspection. They say, look, based on introspection, we have axioms, what experience is like. Experience exists for itself. Experience is specific. Experience is unitary. Experience is definite. Experience is structured. You see, so basically what Robert's saying is like, well, they were taking this as axioms. I don't, um, I would like to see introspection worked on a lot more. If that was so productive, they could get you 5 axioms, right? What if they put in another 20 or 40 years? What would that give you, right? So if you kind of challenge them or nudge them and say, hey, like, is this what you mean by structured, or is this what you mean by structured? I think that opens up introspection as a tool, like, because
yeah.
to acknowledge that. And I think like in the active inference, we also have the situation where, we talk about surprise, we talk about beliefs. Where is that, like Robert said, like, where is that metaphor coming from? Those words are introspective words, right?
Mhm.
Is that a misuse of introspection? Is that a misuse of words? Or like,
Why do you say those are introspective? Why do you say surprise and belief are introspective words?
well, because we know what surprise is because we experience surprise personally inside.
Mhm.
And I suspect, that like Carl Friston and Bayesian thinkers, etc., they took that word surprised, right? And then they said, okay, well, when you have, and also like a belief, what's a belief? We know what a belief is because we have beliefs, right? So they planted this on the mathematics of forward-looking probability. And they said, okay, this is a belief. Now, is that a metaphor? And is it not? And is it hurtful metaphor or a helpful metaphor? Like, what's the status? It's absolutely confused. So, I mean, I think like Daniel could criticize me to say, oh, you're using surprise Andres as an emotion, not as Bayesian surprise, the technical term.
Mhm.
But where do they come up with this technical term? They came from, surprise. And why don't they talk about sadness? Why don't they talk about, relief, right? Why do they only talk about surprise? So is that a problem with the emotional words, right? Like, no.
Right. No, it's occurred to me when I sat through the IIT workshop in Venice. I think that was 2 years ago yeah, almost 2 Septembers ago. It
Mhm.
struck me that it was very focused on like physics stuff, time, space, the
Mhm.
structure of experience, unity, separation, but it was very lacking in emotional content. Like that was a thing I definitely remember is
Oh,
like, where's the emotional content of human experience, which we all experience, right?
well,
When
I
I hear
would,
you talking, Andreas, anyway, that's what's coming to my mind
that's
actually.
where, yeah. And so I would love to talk with you, connect with you afterwards. I'll write to you. But what I've done for 42 years, I'm 60 years old. So since I was 17 and even before that, I wanted to know everything, apply that usefully, have this comprehensive understanding through, let's say, the lens of human experience, human experience. And so what that ends up with is this metaphysical language or like a language of wisdom that's conceptual language that I think is universal. I think we all have, but we're absolutely normalized not to think in terms of it. And what you're doing, with virtual reality is making it possible to communicate that and kind of bring it back. So, for example, when you talked about those 5 selves, the first 3 are what I would call like 3 levels of awareness. the fundamental levels of awareness. So you talked about the embodied mind, which I think was kind of like the bottom up, and the perspectival, which would be like the top down, and the volitional. And so the way I would say it is, I would say that the embodied mind is adding a first level of awareness. The perspectival mind is like an awareness of the awareness, but the volitional is awareness of the awareness of the awareness, like the, how to compare them. So the body itself is saying what we know. We know our bodies, right? 100 billion neurons are telling us. But the perspective self is telling us what we don't know. And so we have a conceptual language of maybe 100,000 black boxes. Maybe that's the Markov, blanket for the generative model. Maybe that's the cortical columns. But those are really what we don't know. Every word we use is really saying horse. What's a horse? And then we get an image of a horse. So these two minds are in. Now the crucial, this is both robotic. We go through motions all day. We have this prattle in our mind of all these cliches. What gives us volition is that we can line those up and then choose which one to do. Should we be embodied, or should we be like stepped in or stepped out? So then to bring that to what you were talking about, so my whole practice has been to let go of all my prejudices, like just disembody myself, as much as possible. Evolution is the history of the disembodying mind. So just to kind of like let go of everything in my body and let go of all my preconceptions, throw away my generative model and just sit in that void. You see, where like you have these, what you call symbolic degeneracy. So I'm just sitting in this void. What do I see? And I see things like divisions of everything. I don't really see them, but if you define the complicated things in terms of simple things, but how do you define the simplest things? They have to be defined in terms of each other. So let's say like a 3 cycle, like you take a stand, you follow through, you reflect, you take a stand, you follow through. That's the basis for the scientific method. Science has never proven it or established it, but that's basically foundational. Or like free will and fate, like opposites coexist, as in free will, but you can also think it's all the same as in fate. Well, the mind moves very easily from free will to fate, but it doesn't move the other way around. So that's like and so for existence, you need 2 points of view. Like you need to be able to say, maybe this chair exists, maybe it doesn't. I have a question. If it exists, it doesn't, and so on. So just to speak to what you were saying and the question you raised, psychedelics and Numadelics, right?
Yeah, that's right.
They may, seem to be similar in certain ways, but I would think, and I've never used psychedelics, but I think that psychedelics tear apart the first 2 minds. They tear apart the embodied mind. They sever them, basically, the embodied mind, the perspectival mind. And that's a very strange thing. I think that's how schizophrenia, basically, it's all about. Schizophrenics live with a disconnected embodied mind and a perspectival mind. At least that would account for all their symptoms. So when people are taking something, they get to feel what it's like to be schizophrenic, and there's things to learn from that situation. But see, what you talked about was not disidentity, but like identification. You see, you talked about the opposite, where when people, when you reduce, I think, maybe it's because you're reducing it, simplifying it, whatever. People can feel the volitional self naturally wanting to identify. So when its whole job is to align what we don't know and what we know so that they have the same information. So they just start to feel this whole practice of, it's much, I don't know, maybe it's just strange. I think that's what they're doing. And so it's maybe the opposite. Now, so when they have psychedelics, right, and then you put them in this situation, you see, they had a disidentified mind. Now it's identifying itself. That would be the claim.
Okay,
They're
interesting.
doing opposite things. So in some ways it looks the same. But does that?
Yeah, well, that's a very different way of thinking about it than I was offering. But I think it's fascinating, actually. I guess I was thinking, well, I said what I was thinking. I was thinking about predictive processing, like, but you're saying that they're definitely working in opposite directions that I wonder if there'd be a way to test that.
Yeah, and so
Which explanation
we
was
could talk. We could talk about that, but just to
Yeah.
kind of push this further and take it back to your electrons, and just to show you like how deep this thing is, because someone like Ian McGilchrist would say, well, this is a left brain, right brain thing, but he doesn't add the third brain, which would be somewhere deeper, like in the thalamus or basal ganglia or whatever. because you have two hemispheres, one that's kind of championing the embodied self and one that's championing the perspectival self, and it's balancing them. And so it can be implemented not like that, but that's the user requirements. But if you go through these divisions of everything, like I call them, it turns out I think there's 8. There's 8 of them, and they make an 8 cycle. So like for knowledge, you need 4 levels,
Andreas,
like the what, how,
I'm
why.
sorry to interrupt you. So this is a Q&A. So you need to ask.
Yeah, so I just finished the point.
Yeah.
So what I did was I mapped that with Bott periodicity is a thing in math. It turns out Bott periodicity gives you combinations of 3 quantum symmetries which relate to these 3 minds. So time reversal would be like embodied, that you can go back and forth in time. The perspectival would be this particle whole where what is and what is not can be flipped back and forth. And the volitional is the combination of the two, where it's like mirrors, you get mirror symmetry. And so basically you get 10 combinations, but the point being that those are the 10 combinations experienced by a non-interacting fermion, a non-interacting electron. Like it's built into everything that it just interacts with itself, nothing else. And that defines basically selfhood. So this idea that you can like an electron can step in and step out because of the way the Hamiltonian is conjugate symmetries. Or if you have both of these symmetries, you get all 3. Actually, if you have the mirror symmetry and you forget about the first 2, if you're just in that, what you call symbolic degeneracy, then you have that energetic coalescence. The electron has this twofold relationship, basically with the void, with God, or whatever. So we could talk about that, but
yeah, it could be cool if you sent me those, because we have a whole bunch of other features we've developed for this framework that I did not talk about here, but like some of the things you talked about, like mirroring symmetry, are in there.
Okay,
And
we'll
we
talk
kind of
then.
stumbled on them as fundamental things for people to understand themselves in the Numadelic world. And so if you have those schematized, maybe we can follow up and I could look at those and maybe I could do a mapping of what we would look like that we would have on an experiential level that comes from that formalism. That could be cool.
I hope to continue. Thank you, Robert. Thank you, David.
Thank you, Andreas. All right. Are there any other questions from the audience? So if there are no other questions, I think it's Carl's turn now for questions, answers.
I don't have to do questions and answers, though, do I?
No, I don't think so. But last time you did a lot of questions. Now,
Oh, right, yes.
with me at least. Will you do
With
it?
you, yes.
Yeah.
When you invite questions, you do. Yeah, and Andreas, he tends to get quite excited. I think we'll have to have a rule that if he talks for more than 8 minutes non-stop, he has to be stopped until he gets less excited by it. But it's nice to hear that excitement being invoked by our guests. So yeah, that was a really literally mind blowing, if not opening, presentation and subsequent discussion, touching upon certainly passionate interests of both Robert and Andreas. I'm going to take a slightly more sort of pragmatic. I'm going to use my time to feedback, so I can imagine you're quite tired now. I'm just going to focus on the specifics of how you might engage neuroscientists and possibly also extend the scope of application of this domain in either therapy or indeed in a commercial setting, just to try and identify likely people that you could be talking to or likely procedures that might be useful. To do that, I'm going to also offer a fairly simple and mechanistic explanation that would link a lot of the phenomena that you've been talking about, and just to put this in a nutshell, what I think would sort of gracefully combine the theory, the appeal to the rhetoric that emerges from quantum mechanics, to the neural correlates, say, as measured by EEG, of these psychedelic and Numadelic states. I'm going to suggest that it all boils down to the neg entropy of your posterior beliefs as encoded by your neural dynamics. And by the neg entropy of the posterior beliefs, what I also referring to is the precision of my posteriors. And as you've rightly noted, the whole rebus perspective offered by Robin rests exactly on getting those negentropies or estimates of precision right in a hierarchical setting. And it also speaks to something that you mentioned or covered in the exchanges and in the presentation, that it's not just a question of there being a particular precision or width of some probability distribution over what you think is causing your sensations. You also have to estimate that and estimate the estimates of that. And you have this sort of recursive, metacognitive, self-referential aspect that I think underwrites the phenomenology. So, in response to your disappointment that IIT didn't have any emotions, then I think one way of phrasing that is what you'd like is a mechanics of phenomenology, the qualitative experience of what it feels like to possess these kinds of technical, mathematical, or Bayesian beliefs. Because of course, you're absolutely right, all of you, that borrowing words like surprisal and self-information from information theory and applying words like surprise can be very confusing. So in my world, surprise just means exactly what it says. It's a negative log probability of something. To put a phenomenology on that, to put feelings on that requires a lot of heavy work. And I think it is heavy work that you are addressing, because you're now thinking about the composition of the actual experiential correlates of this, and the simplifying model, which is basically an extension of the rebus hypothesis, but you're actually looking at the balance of your prior precision or prior negentropy and your lower sensory precision or sensory negentropy. So if you just put that rebus story into nest it within another rebus story, I think you have most of the machinery, at least the hypotheses, that start to get at the phenomenology. And if you can do that, then there should be some fairly simple, well, relatively simple, neural correlates of the ideas that ensue from that formulation, that you could use the VR stimuli as an experimental probe in order to reveal the electrophysiological evidence that yes, this is this particular architecture that underwrites the phenomenology that you want to talk about. But by phenomenology, I'm talking about not the really abstract and wonderful sort of dimensions you've been talking about, although I am very sympathetic to formulations of the essence of minimal phenomenal experience. I'm just talking about the ability to lose phenomenal transparency, to know I'm looking at something, and to know I'm looking at something in a trippy way. These are remarkable capacities, and it does suggest that you've got this sort of inference, self-inference, or self-modeling of a particular sort that must be there if you had a phenomenology. Even before you can actually talk about it. So in that service, I'm just going to whip through a number of papers that I think would be useful should you want to write the abstract with Melanie, for example, that motivated why you were looking for these particular changes in connectivity architectures in the visual hierarchy during exposure to the VR, the illusory phenomena induced by the VR, and possibly crossed with psychedelics, and clearly you've done that in a behavioral setting or a subjective report setting. So it would be really nice and potentially very exciting to do that in conjunction with electrophysiology, high density, ultimately.
Absolutely, yeah.
And Melanie is probably the perfect person, but I will mention a couple of other people you might want to liaise with, or possibly loop Melanie into your collaboration with Melanie, expand that slightly. And I say that for two reasons. Melanie obviously loves your work, has very aligned interests and passions, is one of the world's expert on integrated information theory, but also was the first person to do a dynamic causal modeling study of altered consciousness. And by dynamic causal modeling, this is a sophisticated complex system modeling applied to high density EEG data, and allows you to look at the connectivity within and between different levels of the visual hierarchy. And that's important because the precision that we are talking about, the negentropy that underwrites the precision or the Bayesian blur on your posterior beliefs, that itself has to be estimated, which may give rise to the phenomenology, is physiologically thought to be mediated by the excitability of certain neural populations, specifically in predictive coding schemes, the neural populations reporting prediction error. So if I've got some prediction error halfway up in a deep iris, so vision down here, prior beliefs doing people and me up here, then the excitability of prediction errors at an intermediate level of the hierarchy mean that if they register a prediction error, a mismatch between the top down and the bottom up, then they're going to broadcast it and send it to the top with much more potency, and they're going to have much more effect on the belief updating, the Bayesian belief updating at the higher level. And that means that if you can formulate your ideas in terms of the relative precisions in a hierarchical setting, in the visual hierarchy, that makes a difference between abstract concepts and sensory percepts, low-level elemental percepts, then you can propose that one empirical measure of this is the intrinsic excitability, and that can be actually estimated from EEG data with suitable neural mass models and conventional electromagnetic forward models. That's an established technology. I repeat, Melanie deployed that over a decade ago now, looking at minimally conscious. No, it was anesthetics. She was looking at the what happens in terms of my conscious level when I apply anesthetic drugs. And how can that be understood in terms of the collapse of this hierarchical processing through the loss of excitability or precision of deep hierarchical encodings of putatively Bayesian beliefs or sort of posterior beliefs. So I think she would be an ideal person, but she hasn't done that for a long time. So you may need to find somebody who can hold her hand, but there are people out there doing this at the moment. So I'm going to end up just giving you a couple of papers, and so you can read them. And if you like them, contact or get Melanie to contact the senior authors. And if you want me to write a letter of introduction, I will do that.
Okay, thank you.
Read the papers first and see how and discuss it with Melanie as to whether you think this is going to be a viable way forward. So forgive me wittering. Let me just grab the screen. Got to send a request to stop you sharing so I can share.
Yeah, I'll stop sharing. Yeah.
Good.
Also, maybe if you could email them the references. I don't know. I think I was on the email thread when Melanie first introduced you to me.
They will be recorded.
All right.
They're recorded and you can.
Okay. Okay, then that either way is fine. Yeah. Yeah.
Yeah. So to make my life easier,
Fair enough.
I deliberately show the title so there's a recorded documentary.
As long as I can get the recording, then that's.
Oh yes, I'm sure you'll get
right.
the recording. No problem. Don't you worry about that. Okay. This is in no particular order, so forgive me, but I just wanted to highlight the writings of a gentleman called Jakob Lemanowski. And I'm doing that because he is not a student of Thomas Metzinger, but certainly has really some very interesting conversations with and is an admirer of Thomas Metzinger, but is much more physiologically grounded and has, for many years, possibly nearly 10 years now, been working on variants of things like body ownership and rubber hand illusions of a quite finessed sort, actually using virtual reality with some virtual gloves to try and induce these illusions, and specifically has then used dynamic causal modeling in order to make inferences about why it is that we get these body ownership illusions and how that can be explained in either attenuating or augmenting the precision of certain prior beliefs to reconcile irreconcilable information. And he also has worked with me and used to be, and possibly still is, I haven't spoken to him for a few weeks. Sorry, I haven't spoken to him for several years, but I occasionally get an email. Last one was about a few weeks ago. An expert in active inference. So I've just picked out this, as an example paper just to highlight his name. This particular paper is indeed understanding visio-perceptive, how we resolve visual versus feeling information when they are irreconcilable given our normal prior explanations for these multimodal sensations, and how with a suitable adjustment of the negentropy or the precision afforded our Bayesian beliefs at different points in the sensory motor hierarchy, one can explain the emergence of these illusory phenomena. And I think this paper actually used simulation and then verified the simulation using empirical results. So it might be quite a good model of a very simple sort for the much sort of higher level, deeper kind of literally deeper visual hierarchical applications that you're interested in. And interestingly, he a similar approach dealing explicitly with the rubber hand illusion was applied by Jakob Howie's group, and in particular with his student Brian Patton, again, over 10 years ago. Now, I mention this group because Jakob Howie is another expert in active inference and the free energy principle. They work in Melbourne. He also partners with somebody called Adil Razi, who's going to come up later, who's just got a very accommodating Australian MRC grant to study psychedelics, and Adil is also an expert in dynamic causal modeling. So he's going to be quite a figure. But just to remember, Adil and Jakob work in the same university, and they talk to each other. So it might be just, it might be useful for you in terms of background reading, just to get a flavour of their particular interests and expertise, just to read this early work. Sorry, yeah, I've just put this in. If you haven't read it, this is the foundational paper that talks about in predictive processing and specifically predictive coding, where this story is probably best rehearsed. There are two things we have to predict to make sense of things, to make sense of the sensorium. We have to predict the content, but we also have to predict the precision of that content. So the way that this is described in this paper is that if I wanted to make an inference on the basis of some statistical data, I would have to measure the group mean. For example, if I was testing for an effective drug on a population, I would have to measure the actual content or the effect size in terms of the group mean. But to make sense of it, I also have to estimate the standard error. I have to estimate the variability, the dispersion, the blurriness that you were talking about previously. So that means, and that's usually the more difficult, and certainly from a psychiatric perspective, the more vulnerable part of the estimation problem. And I think it's that part of the estimation problem that has to be solved. You are tapping into with when you're talking about these illusory phenomena. And this basically goes through the underlying maths of this, which is relatively simple, which basically equates this negentropy or precision, which has to be estimated, with the excitability or neuronal gain afforded prediction error units in the brain. And from a psychological perspective, this just is attention, or a certain kind of attentional selection. It just basically picks out which prediction errors I'm going to listen to in the service of hierarchical belief updating in the brain. And you can verify that by appeal to classical paradigms like the Posner paradigm. So you actually direct your attention, you set people up to think that something's going to happen over here. And also things like biased competition, which you may or may not want to refer to, which was a sort of 1990s explanation for why we perceive one thing and not another thing, for example. and there's lots of physiological evidence suggesting that these perspectives have some explanatory scope, and all of these perspectives can be subsumed under sort of attention as precision. And of course, attention is crucial from your perspective, because that underwrites is one perspective on the phenomenology. So, what are the perspectives you could adopt? And do you know Lars Sandved Smith?
I don't. No, I don't. No, I
Okay.
know. I know that paper, but I don't know who Lars is.
Okay, right. Well, perhaps it's sufficient just to know the paper then, but certainly he is, I wouldn't say a protege, but certainly is deferential to Thomas Metzinger, and indeed was the winner of last year's. So Thomas Metzinger had an MPE prize last year for the best essay that provided a formal or computational account of minimal phenomenal experience, and Lars was the first author of the winning paper. But this particular paper, I'm hoping, will have the key graphic that makes this point, which you've already, and also Andreas has mentioned, that it's all about estimates of precision here in terms of a variable gamma. It doesn't have to be, but in this particular graphic. So this precision would be, say, the sensory precision. It would be, in a very simple-minded way, if you asked your subjects just to look through blurred glasses. So instead of doing your extremely clever quantum blurring on the basis of a very precise RGB feed, if you literally just blurred everything. So a simple explanation for the subject would be, oh, somebody's put a smoke screen in front of me, or I'm looking through this through. So that would be basically a manipulation of the sensory precision, or the precision of the likelihood mapping from your sensory inputs to your first level early visual processing. And then you get higher in the hierarchy, where now you've got, say, representing particular objects, and you've also now got the job of now predicting the precision of the likelihood. So this level has its own precision, and probably at this level you are now blurring. So now what used to be an object which was could be recognized with high degree of precision, so that there were no prediction errors, which could have just been the woman sitting there without any quantum blurring, is now no longer an apt explanation of what's going on, because it doesn't explain the lower level information. So now you're going to have to downweight your precision of your prior beliefs at this level, and possibly also at this level, if you think there's also a degree of just blurring the entire vision. But this process itself has to be estimated. So now we're going to the now we're getting to the level where it's not quite self-modeling, but it's certainly looking at the having a model of the relative precision of your prior beliefs and your likelihood beliefs, for example, or your sort of sensory posteriors. And if they are in balance, fine. But if they are behaving oddly, you might sort of change, you might do belief updating about the precision or the entropy of your lower level beliefs. And I think that this is probably what you were trying to say right at the end, when you got this sort of unexpected 40% reduction in the awareness of having a trip, when suddenly the precisions at both levels probably will be brought back into line again. So if the drug reduced the precision at the high level, and you now had blurred images at the low level, although the precisions were both low, at least they were now in balance.
Oh, interesting. Okay.
Yeah. So you don't need to do anything else, because they're now in balance again. So there's no evidence that you're having a trip. You would only know you're having a trip if for some reason you couldn't make sense of very precise data, or you were making too much sense of imprecise data. So your precisions were too high at the intermediate, say, at the prior precision, or low, or vice versa. So what the story here is that it's the relative precision. It's always the balance that matters, and of course that balance also has to be estimated. So, that means you've got to be able to recognize when you're in balance and when you're not in balance, which means that may be the remarkable capacity to lose all transparency of my perception, both at the sensory and prior level, and to render it opaque. So I now know that I am perceiving something, and I am perceiving something in a possibly odd way. So you need this machinery before you can even recognize that your perception is not what it normally is, i.e., I am tripping. And so, I think that this construction, this sort of hierarchical construction or metacognitive construction that is focused specifically not on the content, but on the context, where the context is exactly your sort of quantum uncertainty. Bearing in mind that you always have to estimate the uncertainty, which is the precision, in order to get Bayes optimal precision. So that's why I put that paper up. You don't need to contact Lars, but just to for your entertainment, just to join the dots in terms of the sort of the thought leaders in this space. I repeat, Lars is a fan of Thomas Mitzinger, as is Jakob Limanowski. So it all fits together quite nicely from their perspective. There's a mathematical version of this written with a mathematician who was my PhD student, called Lance da Costa, which as a physicist you might also enjoy reading. So it tells a very similar story, but it's cast purely in terms of Bayesian inference and the Bayesian mechanics that attends that. So I won't take you through it, but for your entertainment, there are mathematical versions that Anil also subscribes to. Coming back to Jakob now, and I just put this in as an alternative to reading his physiological DCM, dynamic causal modeling analyses, because this was a sort of forerunner of that story about phenomenology and its role in rendering transparent perception opaque, so that you are looking at it. I think that's the first baby step you'd have to take in order to get any phenomenology of the kind that you're interested in. And this was quite an interesting treatment, again, largely articulated by Jakob for Thomas with my help. It's a bit dated now, but you may enjoy reading that. This now, yes, that's fine. Right, let me just. I put this paper here because it was something you said which made me think immediately, oh, it's interesting. This paper is just here to make it clear that a lot of the heavy lifting in predictive processing and hierarchical predictive coding in the brain is about predicting the precision. So it's not just about top-down predictions of the content to form a prediction error. You also have to predict the precision, the excitability of the prediction error units at every level. So again, we're talking about predicting the right balance, and of course that itself also has to be predicted. But to make it clear that this is not magic, there are well understood neuronal circuits that implement this kind of precision control in terms of gain control and attentional selection. This paper just demonstrated in the context of feature ground separation in the visual context, just looking at the mathematical details of this dual kind of precision that's going on at every level in a cortical hierarchy, and then just illustrating it, yes, in terms of feature ground selection in this particular instance. So the point I thought actually there was a. Yeah. So I'm pointing you to this paper just to demystify this in terms of the underlying neuronal circuits. There's a clear cut, and there have been other papers subsequent to this written about how this kind of gain control would work, and it is on these synaptic messages that, of course, the psilocybin would work. And from your perspective, in the visual illusion, the equivalent desensitization, say, of intermediate prediction error units would not be induced by a drug, but would be induced by top-down predictions that now, okay, I cannot synthesize, I cannot explain this visual input in terms of well-formed, visually precise human figures, but I could if I now have this concept of a spirit. This is what they would look like. But
Right.
that's,
Okay.
that now means I have to suspend my very precise belief, oh, this is definitely a person, or this is definitely. So now I have to actively reduce my precision in exactly the same way that the psychedelic would, in order to allow for other explanations of a more spiritual or ghostly kind to provide an adequate explanation. And so you can see there's a common mechanism that could be, if you like, mediated by a common synaptic mechanism of just setting the gain or neuromodulatory excitability of certain, in this instance, pyramidal cells in the superficial cortex of some intermediate visual level in the hierarchy. Again, you don't have to read that, but that's there should you want to. Now, so what we're doing now is just trying to find likely consultants or collaborators that you could engage. I suspect you probably with Melanie would be the best thing. I have a deja vu. I think Melanie mentioned she wanted to sort of get back into DCM again, and it may have been because of this, but I can't quite remember. I also have a deja vu of somebody wanting to do crossing psychedelics with exactly the kind of stimuli that you've been talking about. And I'm just wondering whether you've already been collaborating with these people, but I can't
No,
remember.
I haven't. So if you can think of that person, feel free to connect them. I haven't. This is all
Okay.
really like, it's actually the synthesis of the stuff I've done. This is kind of the first time I've presented that a little bit. So I'm very interested to do that moving forward. And if you run across
Right.
anyone on your
Well,
travels, by all means.
I think I know who it is, and I'll show you in a moment. My suspicion is that you should read around what they've written, and if you and then make a decision as to whether you want to reach out to them. If you do, let me know, and I will write you a letter of introduction. So first of all, let's just deal with the simple DCM of no, not simple. So I think there are two agendas here. One is basically to work with Melanie and deploy state-of-the-art dynamic causal modeling to the high-density EEG studies of this kind of VR. What she will have to do is to either employ a postdoc or reskill herself in current state-of-the-art on how to do this. It can be done, it is being done. So effective connectivity is basically a term in imaging neuroscience that describes the directed connection strength of one neural population and its effect on another one. And sometimes the other one can be the self. So you get recurrent self connectivity. And it's that recurrent self connectivity that is usually interpreted in terms of the neg entropy or the precision we've been talking about. So people have, and this is the Adil Razi that I was talking about before, who is at Monash Biomedical Imaging, where Monash is the home to Jacob Howie, who was the other, who is one of the two key philosophers, or one of several key philosophers in the active inference free energy principle space. He's also, interestingly, Jacob also is the lead scientist in the fourth of the Templeton Foundation adversarial research collaboration pitching active inference against IIT. So it's a small world, but Adil Razi is a sort of, if you like, the empirical expert on dynamic causal model for steady state responses, and has now got a grant to study psychedelics and may be very interested either directly or indirectly by skilling up a postdoc of Melanie's, for example, given his expertise. And of course, well, I don't know if you know any of these people, but these are the Swedish
And
people.
friends.
Yeah. Oh, brilliant. Okay, excellent. So that's that. There was another one here. Both again from Adil, but this time actually involving Olaf. the body illusion expert. Again, looking at the modulation of effective connectivity using DCM by psilocybin. So if you ask, do you now want to replicate these things using my VR? They may well have the software and the pipelines and the paradigms, all lined up. So that would be one approach. I would introduce you to Adil. He used to be one of my postdocs and PhD students a long time ago, and then you can take it from there. Another approach, which this is just an example that Robin, one of Robin's experiments when he was working with David Nutt, and where they used, I think, actually MEG to look at the coupling in the very high levels in the visual hierarchy in the parietal regions, using dynamic causal modeling to ask the question, have we got increased or decreased excitability? So disconnection from, say, frontal lobes, for example, or a disconnect or loss of control over lower levels in the visual hierarchy. I'm also amused to know that Amanda Fielding's involved. Do you know who Amanda Fielding is?
I know about her through Robin.
Yeah.
Yeah.
Yeah. Unfortunately, she died a few weeks ago,
That's
but
what
she
I
was
saw, yeah.
yeah, she was a character. Anyway, I just put this up to say that there are this was a long time ago now, if I remember, 2013. But there are established ways of using DCM to look at very specific hypotheses about the precision or the excitability at different levels in cortical hierarchies. And Robin may even remember this application. This gentleman now, I think, has largely disappeared from the game. I think he's in Auckland in New Zealand, but I don't know if he's still got access to the kind of technology which you would want. So finally, the people I think who were looking around in a therapeutic and possibly commercial context for ways of crossing psychedelics with other treatments, I thought, including the kind of stimuli that you have been working on for the past few years, are led by a chap called Giulio Ruffini. Have you heard of Giulio Ruffini?
I think I have heard that name. Yeah, I think I have heard that name. I don't remember
Okay.
how. Yeah. I
So,
don't know him, but I've heard the name. I've heard the name
okay.
with VR, yeah.
Whereabouts are you? Are you in Spain or Italy?
In Spain, in Galicia,
So
Santiago de Compostela.
on the other side, you should
Yeah.
find Giulio then. Yeah.
Okay.
At about the same level. So he's a very energetic thinker, friendly with people like Gustavo Deco, who's also in Barcelona, but also with a particular interest in some of the issues that you're interested in, particularly psychedelics, but also the geometry and space-time geometry and understanding perception. He actually likes algorithmic complexity as a description of the kind of optimal sense making you get from Bayesian perspectives, but underneath, it's basically the same kind of maths. But more importantly, he's the CEO of Neuroelectrics, and this is a company. And this company is trying to establish modeling and practical deployments of brain stimulation, either through transcranial stimulation or through sort of crossing things like psychedelics, or possibly what you have to offer in a therapeutic context. So my closing advice is do a lot of background reading of the kind that I've suggested, so you can identify key people who have a joint expertise in dynamic causal modeling and the kind of gain or negentropy control that is necessary to explain the phenomenology that you are interested in, and get them talking to Melanie on the one hand. Then on the other hand, I would approach Giulio and Neuroelectrics and present to them what you presented to us, and then just let it marinate, let them think about ways forward and see if there's a useful project partnership with them. You will find that Robin, I'm pretty sure, is on the advisory board of Neuroelectrics. So Robin should also know about Giulio's work, but he may not know about some of the more technical endeavors and ambitions that Ruffini has been working with. There's a particular lady that you might come across called Francesco Castellano. She was one of our PhD students. and is academically very active, very bright woman, lady. And she may be the person you end up talking to, but if you do talk to Francesca, give my very best wishes.
Okay. She's involved with neuro,
Yeah,
like,
yeah, I think Julia had to go back and do some emergency teaching at the university, so I don't know, but I think Francesca had to take over the running of neuroelectrics for a few months, so it may be that she's the person you end up. But yeah, Julia and Francesca work very closely, but so either of them, if you can contact either of them, I think that would. So this wouldn't be so much the modeling kind side. I think Melanie can do that very nicely. It would be more deployment in a therapeutic context, or at least providing the experimental medicine evidence for it, deployment of this kind of thing in a therapeutic. You know, these guys are always applying for EU grants to push this field forward, and they may, they may invite you to join in, in the subsequent application as a project partner for this.
Okay.
Just finally, from your point of view, that it may not happen, but they have secured first round funding for establishing a Barcelona center for computational neurology and psychiatry. And that's a not-for-profit organization that you may well want to engage with purely academically, in terms of you've got a drug-free sort of kind of psychedelic available, even though you can't call it psychedelic. But you've got an intervention which is non-invasive that could potentially be very useful in terms of bedside medicine, or at least diagnostics. So just keep your eyes open for that. And that Barcelona Center for Neurology, I think it's neurology, or no, it's computational neuroscience. Barcelona Center for Computational Neuroscience. That is also being run by, or set up by, Julia and Francesca, with the help of people like Gustavo Deco at the UF, the university that in Barcelona.
Okay. Great. Thank you so much. I really appreciate your focusing in, Carl, and offering that. That really helps, because especially like you've published a lot of papers, so sometimes it's hard to like know what are the relevant ones. So for someone coming from the outside, it's hard to know like which ones, because as we publish, ideas evolve and change. So you highlighting specific ones to focus on is really, really super valuable. Thanks for doing that. That saves a lot of time and trial and error. So thank you. Appreciate that.
We thank you, David, for being present today and for giving us a wonderful talk. And let's give David one final round of applause for this fantastic performance.
Thank you all also. And Robert, it'd be cool to link in with you and Anil. I mean, I feel like computational neurophenomenology is like what we're kind of thinking about in very
I think the same. Sure. So to tell you what, I will make sure this recording gets to you, so all the papers and connections Carl mentioned don't get lost. Then I'll show this recording to Anil and people in my lab. I even mentioned one of our finishing PhD students about you and your work, and he might even contact you. So I just did that while you were talking. And I'll be in touch with you. And yeah, sure. There seems to be a lot of common ground here.
Cool. Very good. Thank you all so much. I really appreciate it. And if on any of your travels or whatever you stumble across connections that you think could be interesting, please feel free to put people in touch with me. Thank you.
Sure. Thank you. Bye, everyone. Thank you for attending the talk. Okay. Bye-bye.
Adios.
Adios.